Thanks. Everyone can hear me? Sounds like the mic is actually picking me up, so that's great. I'm going to jump right in. It's actually fun to have 3 talks in a row on the same species because I think some lessons learned from those earlier talks will apply here. And I certainly, looking at the Florida analysis, I start to wonder about scale, because are you trying to get populations to live in a corridor system, or are you trying to get them to pass through a corridor to a new population center? And that raises the question about whether you should be using dispersal data versus resident data, which we actually contemplate in this as well. All right. So I'm just going to quickly acknowledge that this work that I'll talk about now is just one of many, many products from a large collaborative working group. And we've been sort of exploring the potential for mountain lion recovery in the eastern United States and Canada. And so this was one of the analysis that we did. With so many news headlines like this, in the last 15 years, cats spotted in eastern places, in the Midwest, all of this area, it really became a question of, well, gosh, it seems to us that everyone assumes they're already coming, right? So why don't we just ask how long it's going to take for mountain lions, which are primarily in this area in the West, and of course, this little pocket down here, I forgot the color, but that area there, and how long is it going to take for them to move and successfully recolonize an area like this? And as you can see from night light, we're talking about a radically different landscape in terms of the number of people and the human infrastructure supporting those populations. We posed those questions to primarily this gentleman here in the funny hat, and that is Tom Glass. He was a postdoc with Hugh Robinson, who works for Panthera at the University of Montana. And we all sat down, we said, what's the best way to answer this question? We want to know, how long is it going to take for natural recolonization of mountain lions to the east? And the approach that we sort of landed on was what's called an agent-based model. And it's sort of built on a step selection function, which Reed so generously explained for us earlier today. But that's the sort of step selection function where you have known locations of GPS individuals, the potential places that they could move, and the agent-based part of it is that you actually allow individual mountain lions in the model to move independently of each other over time. These are super mathematically, computationally heavy analyses. Each run of our model took about 38 days. These are intensive things on a supercomputer, but hopefully as our computers continue to improve, we'll be able to do more of this kind of work. A couple of things right up front. And you should know that Tom is more the mathematical lift on this collaborative work, and I'm more the biology lift on this. So I emphasize biological things in how we built these models. But one is we had to recognize immediately that not all mountain lions are the same. There are resident males, they have a territory, they're wandering around, they're defending that territory, breeding opportunities, etc. We have resident females, which for 80% of their lives have dependent young with them, and they're all maintaining territories, some of which overlap, some of which don't. And then there's this age class represented by that other smaller cat, which we call dispersers or transients. And they're youngsters, males and females, that are leaving their mother and are searching for a territory, but haven't found one yet. And those guys move a little less predictably than territorial animals. The big difference that we needed to recognize right away was that there is a demographic or a gender difference in the dispersal behavior of mountain lions. Males typically disperse more often, almost always, and further than females. And so here's some data from Michelle LaRue and colleagues from a couple of years back, and they looked at 111 dead mountain lions collected in this part of the country. They were mostly struck on roads. Some were shot by people, out hunting, or just because they saw them in their backyard and were totally nervous. But 70% of them, or just over, were males. And so that shows you that sex bias. And the reason that's important is because we can have thousands of dispersing males reach here, and that does not recolonize the East. We actually need females as well. And so because the dispersal distance for females is shorter, and it's generally a slower process, that's sort of going to determine when recolonization occurs. And it's a really important thing to emphasize. You're going to see males all bouncing around, making headlines, but it's going to be a long time as the females catch up. So that's a big one. The other big difference in the natural history of these animals is what residents do versus dispersers. This is resident male mountain lion in black. This is from Washington State, where I currently work with Reed and Glenn and others who are in the room. And this is Highway 8 in the Southern Olympic Peninsula. It gets about 20,000 cars per day. This is Highway 12 coming down right where this cat crosses, is about 8 to 12,000 cars per day. And the I-5 corridor near Olympia gets about 100,000 cars per day. These are big arteries. These are barriers for wildlife. And you can see the residents typically allow these highway systems to become the boundaries of their territories. Whereas dispersers generally encounter them, they struggle with them sometimes, but they eventually cross. And that's important if you want to look at dispersal or connecting between populations rather than having a population live inside a quarter system. And so that was really important. We decided we had enough data from dispersing animals to just parameterize the model, to build the models using only dispersal data. We ignored resident data, we took that out, only used dispersers. The other big thing I'll just mention here is when we looked at the time step, when we had it short, like 2 hours, dispersers don't cross highways. But the second you extend it out to 24 hours, it's because they wander along that highway for 10 hours, and then they're like, okay, this is my spot, or this is my moment, and they would cross. And so we extended the time step to 24 hours, and that was really important to get dispersers to cross highways. Knowing that they do, we had to account for in our modeling as well. Ultimately, the work that built the model is this ridiculously large amount of work. It took us a year just to sort of collate all the information we needed to drive the natural history of the species. And ultimately, when we just boil it all down, what we wanted to know when we estimated abundance and the number of females and how often they reproduce and how many kittens survive and how many were males versus females, we wanted to know that on average, every day, there are 9 female mountain lions, youngsters in the West or in Florida, because they were included in the model, who are setting off to find a territory of their own. And that's what drove the math of the model. Within our model, we have all these little sub-models. And one of the things that's already been discussed is road mortality. So we actually had a bunch of disperser data, so we knew where they successfully crossed big highways. And we had places where they were struck by highways. Glenn, who's in the room, helped us gather that from Washington Department of Transportation. And so with that, we could build sort of a logistic style model where you look at success in crossing a highway, and then we can look at the variables associated with where they successfully crossed for where they were struck by a car. And ultimately, we just built a simple model that looked at the number of lanes and the speed limit in that location at 1 mile segments on highways, and we created a probability of surviving once they made the attempt to cross a highway. We also, I'll just mention quickly, we also looked at all sorts of other causes of mortality, because these mountain lions, as they're cruising and dispersing, they're crossing state lines, different jurisdictions, different management actions, different variables associated with natural mortality, and we had to actually collate all that stuff, and we created it at the state level. So if they crossed into Montana, they had a different harvest rate than when they crossed into Utah. And so all of that was done at the state or provincial level in Canada. To validate the model, we went back in time. We recognized that, that there's been these populations in gray popped up since 1995. These are breeding populations of mountain lions that have newly appeared on the landscape. So we said, well, that's great. Let's go back in time. We'll launch our model in 1995, and we want to see if our model correctly identifies the time period at which the first reproduction was documented in each of these locations. The blue is the best estimate from the local biologists that work in those regions that this is when they think the first kittens were born. And then the model is the squares, sort of the quartiles, and they capture really well, you know, sort of the timing of when these events should have occurred. Pine Ridge being a notable exception, and we actually think it's because in the southeast corner of Wyoming, which shows green there actually weren't any mountain lions there, because the harvest records don't show any mountain lions from that region in Wyoming. So it took a while for them to recolonize that and then to go to Pine Ridge. We also wanted to see whether it would happen in space, right? So we're hindcasting again from 1995 forward, and that's in black where the model predicted we would see new populations of mountain lions cropping up. And you can see that's where they actually occurred. And so not only did it validate the timing of these events, but the locations of these events. We looked at one more bit of data just for, you know, again, trying to build faith in a model, because models are complex things and you want to know that they're working, or at least pretend that they're working so you can forecast. And we looked at mortality. So again, using people like Michel LaRue's data that sort of collated a bunch of mortality data. So these are mostly males, and these are ones that died during this time period that we hindcasted, including the one in Connecticut. And this is male mortality in red as predicted by the model. And you can see that they're even reached the northeast of this country, or our country in Canada, which is super exciting. Like the model predicted that you might even get a cat out in New England. And we did. That is the probable route of that cat that was killed on a Connecticut highway in 2011. So once we had built faith in the past, we went forward. We only predicted forward 77 years. 77 years? Why 77 years? Well, it made a nice round number, 2100. And we just thought, my gosh, what's the world going to look like in 2100? Let's not pretend we know. It doesn't really make sense to go much further than that. You can see that the model does this amazing thing, and I don't think I actually put the full citation up here, but I will happily help you find this paper. There's these appendices that come with it, which show you the locations of the probable source of dispersers, as well as their probable landing location. And both of those are really fascinating for different reasons, of course. But what these numbers are here is for every state and every province, we came up with the probability, or the sort of number of simulations that produced reproduction. A male and a female arrive in the same area, and they find each other in a 5 kilometer square cell that we mapped across the east. And so then they reproduce. So they had to survive, they had to make it there, they had to find each other, and they had to reproduce to create a reproduction event. And so this was the sort of the number of iterations, you might think of it, that produced youngsters in a particular state within the next 77 years. Minnesota, 30% chance. Oklahoma, 32% chance. You know, Nebraska, we were looking at additional populations in Nebraska because they're already there, and also other states. And we did that for every state and province, you know, east of their known population. One of the big things I'll just point out here is this is the primary arteries. You guys are very familiar with that, being road ecology people, but how dense it gets as you move east in our country. And we found that that was important. Oh, this is the number of iterations, if you're curious, like what the math was, you know, so each iteration is, you know, 1,100 females. We're running it 77 years, each one, you know, multiplied by 77, then another 28,000 steps in each model. So that's why it took so ridiculously long to run the models and to produce results. This is another important thing just to consider. When you think about it, you're like, oh yeah, totally makes sense. But it's important to think about it, is that dispersal was faster where habitat was worse, because they would jump from these stepping stones, one to the other. Whereas where habitat was good, meaning contiguous, Florida, Texas, up in Canada, dispersal was slower. And of course, this makes sense. A female doesn't have to go very far to find all the things that she dreams about for her own new territory. So we predict about 130 kilometer advancement of Florida panthers in the next 77 years, 250 kilometers in Canada, 170 kilometers in Texas. And these are because of the different mortality rates in those different regions. It's sort of a depressing analysis in some ways that, you know, we have to expect that about 86% of females moving east are going to die. Harvest came out as number one, meaning like when Nebraska, just to pick on Nebraska, decides to hunt their easternmost population of 26 animals, including kittens. It's like, why would you do that? You know, that is absolutely hindering their advancement east. But a close second was roadkill. And it was a big deal. You know, the probability of surviving all these different highway crossings as they move east, which of course become more and more frequent. We did do some simulations, and it was at the request of a reviewer, in fact. We didn't have the time to do them super well. I don't even know why we landed on the number 9, but we built 9 bridges, you know, hypothetical bridges over the big highways. And we said, does that increase the speed at which natural recolonization occurs? It did not. I don't think the lesson here is that wildlife bridges fail. I think for me, the lesson was 9 is absolutely too small a number to expect to facilitate the natural recolonization of a large carnivore. The good news is that our models estimate that, you know, about 9% of females are going to live. They're not only going to live, they're going to find males and they're going to reproduce. And that we are going to see a slow crawl eastward. This is just to set it in reality for you. This is the Black Hills. This is the Pine Ridge region of Nebraska. This is not that far. I can't remember how far it is, 80 kilometers, 100 kilometers, something like that. It took 20 years for breeding mountain lions to go from here to here. And that kind of puts things in perspective. Of course, that begs the question whether we want to help them.
Yeah.
But that's not a question for this conference. I'll just acknowledge that these are the folks who helped pay for the work. Tompkins Conservation, Duncan McFarland, some anonymous folks, and the Donald Slavic Family Foundation. Thanks for listening. These are all the, you know, mostly the folks who contributed lots of data from the different state agencies and partners and researchers to make the analysis possible. So that's it. Thanks. We can?
2.5.
2.5 minutes for a question, if you like one.
Condition of the wetland. Did you maybe did the model assume the same, like the highway system remain the same? Did you account for increasing volume, new roads, things like that?
We did not. Yeah, so the question was, you added some bridges. Did you account for new roads, new highways, all of that kind of stuff in your forecasting 75 years? We did not. I think, you know, to defend that, we know that our primary system hasn't really changed the last 50 years and that we don't think it will change that much, but I'm not saying that's why we did that. We were just doing it for simplicity's sake. What happens when you add the bridges in? It basically creates these points of permeability in particular areas on a highway so that they could cross and you could reduce the mortality or the potential for mortality to 0 in those units. Yeah. In the back.
Model has utility for spatial optimization of crossing structure?
Absolutely. You know, and we're actually beginning to explore it as we're comparing a circuitscape analysis of a, you know, sort of a traditional step selection function that looks at sort of the probability of a cat being in a particular place, kind of like what Reed was doing earlier on. We're doing that at the national scale now. And we're doing that to look at connectivity, but then we're also going to do an agent-based version, this model, use this to look at what is the frequency that dispersers will cross between habitat patches and look at that as a metric for connectivity and a potential for locations for connectivity. So we are very close to doing that right now. And one of the things we're looking at is this idea of major roads are pretty significant barriers, especially for territory holding mountain lions. And so Reed and I are actually just about to wrap up an analysis where we take the nation's mountain lions and their potential for mountain lions and say, what are the likely populations that we should be managing for based on habitat and really highways? And those we assume that we need to connect in some way. So is it, you know, you could see when he mapped out Washington that there was the ones that were going down the Cascade Range were pretty well connected, but you've got I-90 cutting them in half. Like, so if we can mitigate that, which we already have through 13, 14 new new infrastructures, that's going to be great. But now we need to manage that as a unit rather than what right now is being forced upon mountain lions as game units, state boundaries that don't connect across these game units or management units, et cetera. So, thank you. Yeah.